Planet Earth, atmosphere. Exosphere. The exosphere has no firmly defined top. Instead, it gradually fades further out into space. Air molecules in this part of our atmosphere are so far apart that they rarely even collide with each other. Earth's gravity still has a little pull here, but just enough to keep most of the sparse air molecules from drifting away. Still, some of those air molecules, tiny bits of our atmosphere, do float away, lost to Earth forever. The exosphere is too far above Earth for meteorological phenomena to be possible. However, Earth's auroras, the aurora borealis and aurora australis, sometimes occur in the lower part of the exosphere, where they overlap into the thermosphere. The exosphere contains many of the artificial satellites that orbit Earth. Temperatures. The temperature in the troposphere decreases as you go higher from about 15 degrees Celsius at sea level to below -55 degrees Celsius at the tropopause. The absorption of UV radiation heats up the stratosphere, and temperatures in this layer actually increase with height, from about -55 degrees Celsius to below 0 degrees Celsius at the stratopause. Again, at mesosphere the temperature decreases as you go higher, from about 0 degrees Celsius to below -90 degrees Celsius at the mesopause. The thermosphere is another atmospheric layer where temperatures rise with altitude. The warming is caused by the absorption of ultraviolet light and X-rays emitted from the sun. Ozone layer. About 90% of Earth's ozone resides in the stratosphere, the region of the atmosphere between the top of the troposphere and about 50 kilometers, 31 miles, altitude. The part of the stratosphere with the highest amount of ozone is commonly referred to as the ozone layer. Ozone absorbs the most energetic wavelengths of ultraviolet light, known as UVC and UVB, wavelengths that harm living things. Oxygen molecules absorb other forms of ultraviolet light, too. Together, ozone and oxygen molecules are able to absorb 95 to 99.9% of the ultraviolet radiation that gets to our planet. When UV light is absorbed by oxygen and ozone, heat is generated, which is why the stratosphere gets warmer with altitude. Karman line. The Karman line is named after Theodor von Karman, 1881 to 1963, a Hungarian-American mathematician, aerospace engineer, and physicist. He was the first person to attempt to define the boundary between Earth and outer space. It is typically defined as 100 kilometers, 62 miles, above Earth's sea level. The line is an approximate region that denotes the altitude above which satellites will be able to orbit the Earth without burning up or falling out of orbit before circling Earth at least once. Most scientists agree that the Karman line marks the transition point between Earth and space. Since 99.99997% of Earth's atmosphere is located below this point, it's considered a reasonable height to draw the boundary between Earth and space. It is an imaginary but practical threshold between air travel and space travel. By international convention, this marks the beginning of space where human travelers are considered astronauts. Ionosphere. The ionosphere is a dynamic region of Earth's atmosphere that spans the mesosphere, thermosphere, and exosphere. It is not a distinct layer and actually grows and shrinks depending on how much energy it is absorbing from the sun. The ionosphere is located from 60 to 300 kilometers, 37 to 190 miles, above the Earth's surface. It is divided into 3 regions or layers: the F layer, E layer, and D layer. Earth's atmosphere seen from space. From the bottom, afterglow illuminates the troposphere in orange with silhouettes of clouds, and the stratosphere in white and blue. Next the mesosphere, pink, and the pink line of airglow of the lower thermosphere, dark, which hosts green and red aurorae over several hundred kilometers. Sunset on the Indian Ocean seen from the International Space Station taken by ISS Expedition 23 crew on May 25, 2010. This image shows the Moon at the center, with the limb of Earth near the bottom transitioning into the orange-colored troposphere. The troposphere ends abruptly at the tropopause, which appears in the image as the sharp boundary between the orange and blue-colored atmosphere. The Moon, the Earth's limb and thin blue atmosphere are seen in this photograph taken by an ISS Expedition 51 crew member. The Earth's atmosphere is an extremely thin sheet of air extending from the surface of the Earth to the edge of space. The Earth is a sphere with a roughly 8,000-mile diameter. The thickness of the atmosphere is about 60 miles. In this picture, taken from a spacecraft orbiting at 200 miles above the surface, we can see the atmosphere as the thin blue band between the surface and the blackness of space. If the Earth were the size of a basketball, the thickness of the atmosphere could be modeled by a thin sheet of plastic wrapped around the ball. Indeed, we live at the bottom of an invisible ocean of air called the atmosphere, a thin layer of gases surrounding our planet.